Okay, we talk about datum, and now we're going to talk about it's not the geodatabase yet. We will start with the GIS data structure. So for GIS structure that we have, that's weird. I think I'm just using this way. Okay, so we will talk about the geographic features, review some stuff. And first, what is spatial data? Spatial data like describe location where in ArcGIS Pro, that's where you see those data that showing North America and South America. So, and each North America and each boundary or each point that attach to the attribute data. So which is specified characteristic at that location, what, how much, and when, like population. Now usually you have to right click on it and look at the attribute data. And how do we present this digitally in a GIS? So by grouping into layers like points, lines and polygons. So lines, water lines, or using raster. So based on the similar characteristics, so like hydrography and elevation, water lines, sewer lines, grocery sales, and using either we have a vector model and raster model coverage. So this is the old file and you don't use for a while in ArcGIS info and shapefile in ArcView, and now we just say ArcGIS. So raster model. So for my generation, I really don't classify. So coverage, it's not my generation. When we start ArcGIS, we know about coverage, but we barely use it now. I kind of like, I never use coverage, but shapefile, it's common. And grid data. So sometimes we convert it to grid data and in ArcGIS info or ArcView. And of course, for the imagery data, I do use ERDOS. Okay, and by selecting appropriate data properties for each layer with respect to, we just finished talk about projection, scale, accuracy, and resolution. And how do we incorporate it into computer application system? So we say the DBMS is database management system. DBMS. Hopefully I will remember. So now we will have to talk more about the data structure. So spatial data types and attribute data types, relation database management system, basic concepts is DBMS and tables, relational DBMS. So raster data structures presents geography via grid cells, tessellations, run length compression, qual tree representation, and BIP, BIM, BSQ. Database management systems, relational database management system, representation file formats. So for the vector data structure, we represent via coordinates, whole polygon, point, polygon, node, arc, and polygon things, and file formats. For spatial data, that for continuous like elevation, rainfall, ocean salinity areas, unbounded land use market areas, soils, rock type, bounded, city, county, state boundaries, ownership, parcels, zoning, and moving air masses, animal herds, schools of fish, networks, roads, transmission lines, streams, and points, fixed wells, street lamps, and addresses, moving cars, fish, and deer. So points, and even with some features never change. Yeah, those are fixed. Of course, you can move lamps as well, but these are more feature that move more frequent. It depends your time scale. Attribute data types, so category, name, nominal, no inherent ordering, land use types, county names, so nominal. and ordinal, inherit order, row class, string class. So class 1, it's more like hierarchical, often coded to numbers. For example, social security number, but cannot do arithmetic. It is number, but you cannot do like arithmetic to do the relationship between them. And numerical, no differences between the values, interval, no natural zero, and cannot say twice as much. Temperature, Celsius or Fahrenheit ratio, natural zero ratio makes sense, twice as much. Income and age and rainfall may be expressed as integer, whole number, or floating point, a decimal fraction. And attribute data tables can contain locational information such as addresses or a list of x, y coordinates. ArcView refers to these as event tables. However, this must be converted to true spatial data shapefile, for example, by geocoding before they can be displayed as a map. So this is database management system and contain tables or feature classes in which that have entities, records, observations, features, all information about one occurrence of a feature, columns, attributes, fields, data elements, variables, items that still called arginfo, one type of information for all features. All key field is an attribute whose values uniquely identify each row. So the relationship. We did join. So tables are related or joined using a common record identifier, common variable present in both tables called secondary or foreign key, which may or may not be the same as the key field. Goal, produce map. So if values by district, neighborhood, problem, no district code available in puzzle table. So the solution is join puzzle table containing values, which geography table containing location codings using block as a key field. So GIS data models. So we talk about raster vector. So raster is faster, but vector is corrector. Raster is faster, but raster is vector, but vector is corrector. So the raster data model location is referenced by a grid cell in a rectangle array matrix. So attribute is presented as a single value for that cell. Much data comes from this. Images, Landsat spot, like remote sensing scan maps, and elevation data for USGS. Best for continuous features like elevation, temperature, soil type, land use, and vector data model. So location referenced by XY coordinates, which can be linked to form lines and polygons. Point, line, and polygons. So that you form lines and polygons for sure. Attributes referenced through unique ID number or tables. So much data from comes from this form is timer, dime, and files from the US Census, DLG from USGS for streams, roads, etc. Census data tabular, best for features with discrete boundaries, property lines, political boundaries, and transportation. So the Department of Transportation, of course, use vector data model, but they generate from the raster, like heads-up digitizing. So right now, a lot of work they did was just heads-up digitizing based on the raster data. So raster data we will do is like raster representation using the cells, and wire vector representation we separated point, polygon. So this is like the stream here, and the tree here, the house, tree. So using cells. Of course, there is not just one cell for the house, but formed by different all the pixels. Okay. All the cells here. So representing data using raster model. So different value, like this is raster, fruit is 4, wheat is 2, corn is 1, and fruit is 4. So you see the 4 here, oats is right here, and clover is right here. So Representing data using raster model. An area is covered by grid with usually equal size cells. Location of each cell calculated from origin of grid 2 down, 3 over. Cells often called pixels. Picture elements. Raster data often called image data. Attributes are recorded by assigning each cell a single value based on the majority feature attribute in the cell, such as land use type, and easy to do overlays analysis just by combining corresponding cells values, yield and rainfall plus fertilizer. Why raster is faster, at least for some things. So simple data structure directly store each layer as a single table. Basically, each is analogous to a spreadsheet. And computer database management system not require, although many raster GIS systems incorporate them. And raster data structure, the concept is grid often has its origin in the upper left, but note state plane and UTN lower left, latitude, longitude, and Cartesian center. So single values associated with each cell, typically a bits assigned to values. Therefore, so 2 to the 8th power is 256 possible values. So, but your value starts from 0 to 225. Together, you have 256 possible values. So the rules needed to assign value to cell if object does not cover entire cell. A majority of the area for continuous coverage feature value as cell center touches cell for linear feature such as road waiting to ensure rear features represented. So choose raster cell size 1 over 2, the length 1 over 4, the area of smallest feature to map smallest feature called minimum mapping unit or cell resolution element. So raster orientation angle between true north and a direction defined by raster columns. So class set of cells with same value, for example type sandy soil zone, set of contiguous cell with same value, neighborhood set of cells adjacent to a target cell in some systematic manner. And the raster data structure is tessellation. So tessellation, geometric arrangement that completely cover a surface, so the square grid. So equal length side, conceptually simplest cell can be recursively divided into cells of same shape for connected neighborhood above, below, left, and right. Rock's case, all neighboring cells are equidistant. An A-connected neighborhood also includes diagonals. Queen's case, all neighboring cells not equidistant. And center of cells on diagonal is 1.41 units away, square root of 2. Rectangular commonly occurs for latitude and longitude when projected. Data collected at 1 degree by 1 degree will be varying sized rectangles, rectangular 3-sided and hexagonal 6-sided. All adjacent cells and points are equidistant. Triangulated irregular work team vector model used to represent continuous surface elevation more later under the vector. So the raster data structure run length compression for single layer, that full matrix. So like this is the matrix. So we can see 1 here, 3 is all here, 2 is here. That's the matrix. 162 bytes, and run length row 44 bytes. This is a lossless compression as opposed to lossy, since the original data can be exactly reproduced. So now GIS packages generally rely on commercial compression routines, and the PIC-ZIP is the most common general purpose routine, and this Mr. Sid from Lizard Technology and ECW from ER Mapper are used for images. All these essentially use the same concept. Occasionally, data is still delivered to you in run length compression, especially in remote sensing application. So here, the value through column coding. First number is value, second is last column with that value. So value through column. So this is the column. Then we have 1, 2, 3, 4, and then we have 7, 7, 7, 2, 1, 17, and 3, and then 18. The second last column is with that value. So we have 18 all the way here, and 133, and then 18. Okay. Alright, so now raster data structure, so quad tree representation for single layer. So previously we have the rule length compression, run length. So now here is the quad tree representation for a single layer. So essentially involves compression applied to both row and column. Size of the square grid divided evenly on a recursive basis. So length decreased by half, numbers of areas increased fourfold, and area decreased by 1/4. Resample by combining average the 4 cells value. Although storage increases if save all samples can save processing costs if some operations don't need high resolution. For nominal or binary, data can save storage by using maximum block representation. All blocks with same value at any one level in tree can be stored as single value. So raster data structure, so raster array representations for multiple layers. So raster comprises row and columns by one or more characteristics or arrays. Elevation, rainfall, and the temperature or multiple spectral channel bands for remote sensed data. So this is like vegetation, soil, and elevation. They combine different things. So now how organized into one-dimension data stream for computer storage and processing band sequential. So band sequential, BSQ, band sequential. Each characteristic in a separate file, elevation file, temperature file, etc. So good for compression. Good if focused on one characteristic. Bad if focused on one area. So the BIP is band interleaved by pixel. All measurements for a pixel grouped together. Good if focused on multiple characteristic of geographical area. Bad if want to remove or add a layer. So the band interleaved by line, BIL, rows follow each other for each characteristic. So note that the star in lower left, upper left is alternative. So that we have A, B, B. So for vegetation soil, we have a 1, 2, 3, 4. And for the elevation, we have a 120 and 140, and then 160, 150. So we go counterclockwise, and then once we kind of combine A and then I and then 120. So and then the second cell we put them, and then the third cell. So third cell we have a B and then 3, 1, 2. Oh, this 3, 4. So 1, 2, 3, 4. Not counterclockwise. It's more like S shape, but it's reverse. So then we have a B4. So B4 and 160. So AB. So then we will combine again A, B, 1, 2, AB 1, 2, and then 120, 140. So AB 1, 2, and then this, and then BB, and then 3, 4, 150, and 60. So you go this way, 1, 2, 3, 4. Yeah, this one, 1, 1, 1, 1, 1, 1. Okay, cool. And then the raster structure, raster data structure is database representation. The raw data may come in BSQ. So BSQ, it was the band sequential. So the band sequential raw data can be sequential BIP interval and BIL, which is the band intervaled by line, can be represented as standard data base table. Joins based on ID as a key field can be used to relay variables in different tables. So now we have row ID 1, 2, 3, 4, row 1, 2, 3, 1, 2, 1, 2. Yeah, row column 1, 1, 1, 2, 2, 2, and then the variable. Cool. So for raster, you basically deal with the cells. the cells, and file formats for REST spatial data. So the generic REST data model is actually implemented in several different computer file formats. So the grid is Esary's proprietary format for storing and processing REST data, and standard industry formats for image data such as JPEG, TIFF, and master SID format can be used to display REST data, but not for analysis must convert to grid. So georeferencing information required to display images with mapped vector data will be discussed later here. So, and it requires accompanying world file which provides location information. So image file. So here it should be together. Right here, Word file, and TIFF. So we have image TIFF, image TFW, and the world. So, and then bitmap, BMP, BIL, BIL, and BLW, and JPEG. So we're familiar with all these, but the format should be aware. Although not commonly encountered as a GeoTIFF is a single file which incorporates both the image and the world information as a single file. And the vector model, representing data using the vector model formal application. So the point node, zero-dimension single XY coordinate pair, and zero area tree oil well, and label location line arc, one dimension, two or more connected XY coordinates, road, stream, polygon, two dimensions, four or more ordered and connected XY coordinates. First and last XY pairs are the same. Encloses an area, census tracts, county, and lake. And we're going to move to vector data. So vector data, so it's actually, to me, it's faster because imagery, it takes space to store all those information. The whole polygon boundary structure. Polygons described by listing coordinates of points in order as you walk around the outside boundary of the polygon. All data stored in one file could also store in efficiently attribute data for polygon in same file. Coordinates, borders for adjacent polygons stored twice may not be same, resulting in slivers, gaps, or overlap. How assure that both updated? All lines are doubled except for those on the outside periphery. Not topological information about polygons, which are adjacent and have a common boundary. How relate different geographies, for example, zip codes and tracts. So we did in lesson 2, we dealt with the tracts data, and we used by the first computer mapping program and SimMap in late 1960s. That was in Harvard. They started with the GIS, adopted by SARS and Graph and many business thematic mapping programs. Topology. So the knowledge about relative spatial position and managing data cognizant of shared geometry. Topography, the form of the land surface, in particular its elevation. And remember, right now, if you start ArcGIS Pro, that's how they always give you the topography features there. Topography as a base map. But here, it's about its elevation and some landscape. Alright, so now the data file, whole polygon illustration, we put the line. So for C, we have a C42, 4, and then 2. That's one side, okay? And then for 40, which is right here, 40 is right here, and then this one is 32, and then 30. So for C, that's the points that we have. And let's see what is 30, 30, and 32, 32, which is right here. So they have to be in order. That's how we stand for its polygon, and then we put numbers there, and then 1, 2, 3, 4, and then to 1. Then will we have A? And for B, we go 2, 5, 6, 3, 2. Then we have a B. And you have to go back to that, so to show it's a segment. So 3, 6, 7, A, and then go back to 3. So for E, if we start 11, 11, 10, 9, 4, we don't have to say 10, and then we shouldn't have a 5 here. It's not correct. So unless we go this way, yeah. So yeah, 11, 12, 5, and then 1. You don't have to put 2 here. So 5, 1, and 1 to 9, and then 9 to 10. 10 go back to 11, or you can say 11. But here it's a counterclockwise, 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 counterclockwise. Go back to 4, counterclockwise. Oh, clockwise, not counterclockwise. Sorry, my bad. So it's clockwise, not counter. Counter will be 4, 9, and then A, 3, 4. Okay. It's clockwise, okay. Vector data structure. So the node, arc, and polygon topology. So comprises 3 topological components, which permits relationships between all spatial elements to be defined. Node does not imply inclusion of attribute data. So the arc node topology defines relations between points by specifying which are connected to form arcs, and defines relationships between arcs lines by specifying which arcs are connected to form routes and networks. And polygon art topology defines polygon areas by specifying which arcs comprise their boundary. Left-right topology so defines relationships between polygons and thus all areas by defining from nodes and to nodes, which permit left polygon and right polygon to be specified. Also left side and right side arc characteristics. So now node, arc, polygon, and attribute data relational representation and database management system is required. So now we have here, so Birch and Cherry and Smith real estate and for the arc table, so which are the part, and control, stop, yield, none, and crosswork and stuff, we record all those information. Representing point data using the vector model and data implementation. So we might have to find surveying data to look a little bit, because sometimes when you work for property appraisal, they might need those information, and it could be totally different from but it have some overlaps here. All right, so we continue. So representing point data using the vector model and data implementation. So features in the thin coverage have unique identifiers: point ID, polygon ID, arc ID, etc. So common identifiers provide link to coordinate table for where, attribute table for what. Again, the concept are those of a relational database, which is really a prerequisite for the vector model. Okay, so now for the vector model, so now the team, triangulated irregular network surface. So elevation points, nodes chosen based on relief compressity, and then their 3D location x, y, z. You add the z data determined, and elevation points connected to form a set of triangular polygons. These then represented in a vector structure. And attribute data, so associated via relationships, database management system, slope, aspect, soils, etc. Advantages over raster, fewer points, captures discontinuities. So example ridges, slope, and aspect easily recorded. Disadvantages relating to other polygons for a map overlay is compute intensive, many polygons to calculate, and the relationship is crazy if you have more features there. And the file formats for vector spatial data. Oh my god, I don't want to talk about coverage, but we do have that. Generic models above are implemented by software vendors in specific computer file formats, and coverage vector data format introduced with ArcGIS Info in 1981, multiple physical files, 12 or so, in a folder. Proprietaries, no published specifics, and ArcInfo required for changes. You don't see them anymore. So, for my generation, I don't deal with coverage. So shapefile vector data format introduced with ArcView in 1993 comprises several at least physical disk files with extension of shapefile .shx, dbf, all which must be present openly published specific, so other vectors can create shapefiles. Geodatabase, new format introduced with ArcGIS 8.0 in 2000. And now we're using ArcGIS Pro. Multiple layers saved in a single MDB, so MS Access-like file, proprietary next-generation spatial file format. Shapefile are the simplest and most commonly used format and will generally be used in here. So we use shapefile all the time, isn't we not? And we all saved in geodatabase. So even the ArcGIS Pro still heavily rely on shapefile. We still have to get shapefile. It didn't change the data structure. Although the format interface changes in ArcGIS Pro, we will talk about it in later part. But it just add a base map. The only difference between the ArcGIS Pro and everything. So now. The version, so we see the licensing. The version last time, I gonna get expired. So now I have advanced feature. So it didn't say this never expire, but the advanced will expire. I don't know, but hopefully that authorized Pro to work offline. Maybe I will do it. Yeah, oh no. Not authorized. Okay, so now gonna back off. So each time I have to sign in, and I think the licensing here, everything you control here instead of and the Python and everything you control here, and you even have a portal, and it's a lot different than the old version of ArcInfo or something. I really don't like to hear those words. They're just like grandparents' words. All right. Geographic data, another perspective. So object view, the real world is a series of entities located in space. An object is a digital representation of an entity with three types: a point, line, and area, which is polygon. The same entity can be represented at different scales by different object types. Multi-representation behavior can be associated with objects, thus they can change over time. And the field view. So the real world has properties such many continuous over space. Every place has a value. May be represented as a raster data or with vector data as a thin triangulated irregular network, field or object. If the field value is a categorical or integer variable, then places with the same value. For example, crop type can be grouped into area objects. So like this, the world is how we decide to look at it. And representing the surface. So for example, look this one representing the surface in that Tagaram National Park, North Island, the New Zealand, and we can look, and we zoom to. That's just one spot here, and here you only see those pixels. But in the real part, if you go there, like this person, I think maybe he's wrong bridge. So he went there, and you can see that it's a lot different. Okay, now overview the representing surface. So the surfaces involved a third elevation value, which is the z value, in addition to the xy horizontal value. So when we deal with a lot of exercises, the z value is, remember here, it is the elevation value. And the surfaces are complex to represent since there are an infinite number of potential points to model. So 3 or 4 alternative digital terrain model approaches available: raster-based digital elevation model, regular spaced set of elevation points, z-values, vector-based triangulated irregular networks, irregular triangles with elevations at the 3 corners, vector-based contour lines joining points of equal elevation at a specified interval, masked points and break lines, the raw data from which one of the other 3 is derived, masked points, and any set of regular or irregularly spaced point elevations and the break lines, point elevations along a line of significant change in slope, valley, dot floor, and ridge crest. Oh, this is common. This one you have to remember. So the digital elevation model, a sample array of elevations z that are at regular spaced intervals in the x and y directions, and 2 approaches for determining the surface z value of a location between sample points in a lattice. Each mesh point represents a value on the surface only at the center of the grid cell. The z value is approximated by interpolation between adjacent sample points. It does not imply an area of constant value. A surface grid considers each sample as a square cell with a constant surface value. The disadvantages: simple conceptual model, data cheap to obtain, and we can generate it easily to relate to other raster data. An irregular space set of points can be converted to regular spacing interpolation. And the disadvantages does not conform to variability of the terrain and linear feature not well represented. So when you use it, you have to be careful. And for the triangulated irregular networks, set of adjacent non-overlapping triangles computed from irregularly spaced points with x, y horizontal coordinates and z vertical elevations. The advantages can capture significant slope, features, ridges, etc. Efficient sinks require few triangles in flat areas, easy for certain analysis. Slope, aspect, volume. Disadvantages: analysis involving comparison with other layers difficult. Control control limes or isolimes of constant elevation at a specified interval, valley and hill, top, ridge. So disadvantages: familiar to many people, easy to obtain mental picture of surface, close line, steep slope, uphill V, stream, downhill view or bulge, ridge, circle, hill, top or basin. Disadvantages: pool for computer representation, no formal digital model, must convert or raster or TIN for analysis, control generation for point data, require sophisticated interpolation routines, often with specialized software such as Surfer from Golden Software Incorporated or ArcGIS Spatial Analysis Extension. So, appendix JS file formats, some additional detail that vendor interpolation for JS data structure, that we have a file formats that we could talk about. And then we will talk about the database in our next session. So the vendor implementation of JS structure, file formats, raster, vector, TIN, etc. are generic models for representing spatial information in digital form. And JS vendors implemented these models into file formats or structure which may be proprietary, usable only with that vendor software like Esri. Published. Specification available for use by any vendor, Esri shapefile or the military VPF format. So transfer formats intended only for transfer of data and between different vendor systems like AutoCAD, DFX format, or SDTS between different users of the same vendor software like Esri's E00 format for coverages. One GIS vendor may be able to read another file format by translation, whereby format is converted externally to vendor's own format. Usually requires user to carry out conversion prior to use of data on the fly, and whereby conversion is accomplished internally and automatically. No user action needed, but usually no ability to change data. Best is natively or transparently, which normally implies no special user action needed, ability to read and write, change, or add the data. So common GIS and CAD file formats. Israeli coverage is vector, proprietary, E00 for coverage exchange between Israeli users. I think that was just history. Right now, we are not working with that. And shapefile, vector, publish shapefile. Geodatabase proprietary. Geodatabase based on current object-oriented software technology. Grid is raster and AutoCAD. AutoCAD, DWG native AutoCAD, DXF for digital file exchange, Intergraph, Bentley MicroStation, GDN, Intergraph, Bentley, and MGE, and a lot of places they use this. And if you study architecture, AutoCAD is needed. So Israeli products right now, I only focus on this, but later part I do have to spend time to do AutoCAD and Intergraph Bentley stuff. So Spatial Data Transfer Standard, SDTS. So U.S. federal standard for transfer of data. Federal agencies legally required to conform, and embraces the philosophy of self-contained transfers. Is example that we have spatial data, attribute, georeferencing, data quality report, data dictionary, and other supporting metadata all included. Not widely adopted cause of competitive pressure and complexity, and perceived disutility derived from philosophy. Wow, that's crazy. Okay, shapefile. So shapefile, and I'm not familiar with this because I never get chance to use it. And even now we did the AutoCAD imported to ArcGIS. It's everything just like intro level, but if you do project, it might be an issue. So Israeli vector file format, so the georelational, so the shapefile we use a lot, native GIS data structure for a vector layer in ArcView. So now it's just ArcGIS, so not fully topological, limited in info about relationship of feature one another, draw faster. So yeah, draw faster, not as good for some fancy spatial analysis. It's a logical file which comprises several, at least 3 physical disk files, all of which must be presented for AV to read the thing. Layer shapefile, geometric shape described by XY coordinates. Layer shape SHX indicates to improve performance. Layer debase contains associated attribute data, and layer SBN is not a must. So this 3 format is a must in shapefile, but this one, layer SBX, not really a database. So though ArcView present file in user via relational concepts, openly published, specified so other vendors can develop shapefile and read them. Okay, so the coverage, not used anymore. Nope, not published, specified. So coverage native GIS structure for a vector layer in ArcInfo fully topological. So it has the topological, this one has not. Better suited for a large data set, better suited for fancy spatial analysis. Comprises multiple physical files, 12 or per coverage. I think I might get some chance. Long time ago, I think I did some coverage. That was like 6 or 5 years ago. So each coverage saved in a separate folder named same as the coverage. Physical file set differs depending on type of coverage, point line, and polygon. Coverage folders stored in a workspace directly with an info folder for tracking. Attribute table stored there. Also, we have ArcInfo required to make changes. Proprietary, no publish. Specify formats for export of coverages for other Israeli users. Important 71 utility in ArcView Start menu can read E00 files and convert them back to coverages. Must convert to shapefile or AutoCAD DSF format to transfer a known Esri data system. So this is just crazy. Okay. So we can talk about now, and I think this will be talking about it again and again, the database, geodatabase, 3 types. Personal multi-user, which is SDE. So geo-relational database, the old classic environment. So proprietary coverages in ArcInfo database, publish shapefile in ArcView, DB4 database based on point line polygon model. So the geodatabase. So the new term in ArcInfo A in 2000 replaced for coverages and support for simple feature point line polygons, complex features, real world entity modeled as objects with properties, behavior, rules, and relationships. AV downgrades complex features to simple features. Personal geodatabase single using user editing store as one MDB file, but access cannot read. AV 3.2 cannot read to be fixed later. Multi-user geodatabase supports versioning and long transactions. User ArcSDE 8 as middleware stores in standard DB Oracle, MS SQL Server, Informatics, and Sybase. IBM DB database 3.2 AV 3.2 can read. So Microsoft SQL that if you get this book, let me show you real quick that it has everything to show you how to link everything. How to once you get the ArcSDE. So I already showed you about this, and the book I want to show you. Okay. Yeah, Learning ArcGIS Geodatabase. So this book for the ArcSDE, it's a good book that I don't have the license. So once I have the license, that I do need to try whether I can table of contents. Perfect. So so once I have the file, then this one is setting up how would you configure an SQL Server Express and link to your geodatabase. So the enterprise geodatabase, how would you set it up? And everything is here. You just need a file. And if you don't get it, what was the name for it? If you don't get it, what was the name? Yeah, you can call Esri Desk Help, and the people are there for you. The raster format, the image files raster supported in several formats. So BSQ, BIL, and BIP and run length. JPEG must load JPEG images extension, and then TIFF must license style of compressed used. Erdos GIS, I use Erdos imagery, and LAN, I never use LAN. A lot of things for you to explore. So georeferencing information require if images to be displayed with mapped vector data. Cells of the raster must be converted into the XY coordinate matrix, latitude, longitude, projector feed, etc. of the map. Store in header file of the raster image. For example, you have the GeoTIFF, or in a separate world file. And for example, like this, be sure we have a both file. That's very important. And grid native proprietary format for a raster file in ArcGIS Info incorporates positioning information, can be read by ArcView. So it's really weird for ArcView and ArcInfo. It's like we never say ArcGIS. So all raster-based analysis require file in grid format, including ArcView Spatial 3D Analyst. ArcView has some limited capabilities for converting to grid format, but generally this requires ArcGIS Info or the PC-based data automation kit. When ArcView serves grid data, it sets it does so in an ArcGIS Info style format or catalog must be used to manage these. So, spatial data engine, yeah, that's the SDE enterprise. That it can support multi-users. So that's what I showed you on that chapter. So Esri middleware products designed to interface with industrial standard relational database management system for a large-scale spatial database. So first introduced with ArcInfo version 7 in mid-1970s. 1990s ArcView version 3.0, and later can read SDE. Both attribute and spatial data is stored in the same relational database management systems such as Oracle, which support SDE. I need to spend time to study a little bit Oracle. It's very important here. Allows mass data capabilities, security and data integrity, mechanism of the relation database management system to be applied to the spatial data. Data is grouped into sets which share common security. Example, all data for a city, layers similar to things, for example, row layer, puzzle layer, features, individual elements, for example, single row. Advantages for large data sets include layers are not tiled, so no reassembly is required. Feature can be extracted as a complete element, for example, entire row. Alright, so we talk a lot about data structure. I know it's kind of, I went into straight, not continue with everything here, but the second part we have to go over the geodatabase again and get into detail. For sure, that I'm gonna spend time and we will do the lesson 4. Everything is about geodatabase, and then I will show how to be done in ArcGIS and along with some concepts. But right now we're spending on concepts. Once the concepts is down, then we will get into the ArcGIS Pro. Okay, see you soon.